Hi, welcome to the October 1 meeting of the Kubernetes VMware user group. Today on the agenda, we're going to talk a little bit about storage and disaster recovery. Some of my usual co-hosts are likely to be joining us late today. Miles Gray is tied up with some activity related to the VMworld conference that's going on, but he thinks he's going to be joining us using his cell late, but he may be in listen-only mode. And Bryson Shepard just slacked me saying that he's tied up in another meeting for now, but it sounds like he might be joining us a little late, and I'm hoping he can join us because we wanted to talk a little bit about a recent incident he had where he was trying to move a Kubernetes cluster from one vCenter to another, and took a little bit, but I guess he figured out enough to get that working, and I'm hoping he'll be able to share what it took to get that to work. A little while ago, we had on the agenda a topic by Gopala about what's new in the vSphere 7 Update 1 release. He's unable to make it today, but he'll join us at a future meeting. But we still do have Dave Smith Uchida. Did I get your name right, or I'll let you say it again if I didn't? And he's going to talk.
Uchida, Japanese.
Okay. He's going to talk to us about the intersection of cloud native storage and data protection. So with that said, I'll let you get started, Dave.
Okay, so I have slides, but this is a very small group, so feel free to jump in and if you have questions, or if you already know all this stuff or whatever, I'm happy to move in a more free-form direction as well. Here's Bryson. I'm Dave Smith Uchida, and I'm currently I'm styling myself as the Valero architect. So I've moved over to MapBU. I've been at VMware about 4 years now. I was the architect on first class disk, and I've been leading up the Valero plugin for vSphere for the last year and a half now.
Dave, I'll jump in, but I've sometimes hear from kind of newbies to this, so maybe a little intro on what Valero even is, just in case somebody hasn't heard of it. And also the acronym, we're horrible at acronyms at VMware. MapBU is the Modern Applications Business Unit. So this is the part of VMware that engineers Kubernetes as well as a full build, run, manage of application things using open source technologies to run on top of Kubernetes.
Yes, and that's a very good explanation. I need to remember that one. And yeah, so Valero is our open source backup product for Kubernetes, and I'll go into the capabilities and some of the internal architecture on that in a moment. Okay, so there's a kind of an open question, or I've heard varying opinions on what kind of data protection do you need for Kubernetes. Some people will say you don't need any, and other people will say, yes, you do. So I tried to break it down, kind of my view of what's going on and what kind of protection you may need. So, Kubernetes, my understanding of Kubernetes is it started out being pretty much a front-end scaler to scale up and scale down compute and to handle what you would consider to be a stateless app. And that may be either something that doesn't actually have any state, or it may be a front end for another service that already controls all of its state and has ways to keep track of all that stuff, and it's already protected. So really, the thing that's running in Kubernetes is really just compute, network I/O, et cetera, that scales up and down as needed. And in that case, if you do just keep revision control on your YAMLs, you're fine, because that's your application. And typically you can kill your application, reload your application for the YAMLs, and it should come up the same way. And all of your actual state is stored somewhere else safely. So that's one model. I think that's kind of the original model. Then we move on to people storing things in a cloud service. So You bring yourself up in like AWS and you put things on S3 and you put things in DynamoDB or whatever services that Amazon, the cloud provider is giving to you. Again, you want to have your revision control on the YAMLs. And you may or may not want to have backups and snapshots on the actual stuff in the cloud service. Some of that will depend on things like scale. As you move into extremely large scale apps, consider like Netflix. The idea of snapshotting and backing up all of Netflix gets a little crazy, and that's not really going to work. And so, an application at cloud scale is usually built to have all of its internal replication, redundancy, et cetera, so that it will not lose data and it can survive all kinds of bad things. The difficulty is that engineering that into your application is hard. And at smaller scales, things like, if you have a terabyte of data in S3, backing that up isn't such a bad idea because it may get deleted for any number of reasons. So that's kind of like, that's kind of my take on things with cloud services, running on cloud service. And now we've been starting to push this idea of running persistent volumes and running applications inside Kubernetes that store their state in persistent volumes managed by Kubernetes. And now, this responsibility of who's going to protect the data has really moved back to the application. So, you need to do things like back up the data in these persistent volumes. You need to back up your Kubernetes resources. There's state now in Kubernetes, like which volume was attached to which stateful set. All these kind of things need to be handled. And so that's where you really start looking at, hey, I want to do backup, restore, remote replication of my application as data. And another model that we're seeing is people actually, they're building applications that keep the application state in custom resources in Kubernetes. So your runtime state, which may actually be really important to you, is no longer in your original YAMLs, right? Your original YAMLs tell you how to set it up and run the servers and so forth. But then they start, keeping track of things in CRs and, like where they are in terms of processing something that might be stored in another service like a database or an object store. And now that information is actually really important. So you really need, when you move to that kind of an app, you really need to back up your Kubernetes resources, even if you don't have any persistent volumes. And that's something that you have to make a decision on, like on an app by app basis.
Dave, can I ask you a question? I'm aware of some of these Kubernetes plugins that maintain state too. Like there's a few CNIs, network plugins, that maintain state associated with the networking implementation. And have you ever seen any big listing of
No.
where these things keep their state? Because I'm thinking, it'd do the world a service, and maybe somebody who is in the backup thing has somehow tried to consolidate that. But some of those store their things in etcd, in which case an etcd might get it, although some of them stored in an etcd that potentially is not the same one used by Kubernetes. And some of them use databases. And I don't know, it strikes me that you might want a general purpose tool that could capture all of this stuff.
Yeah, and it's really, that's something, I mean, Valero will capture it all. Some of the tricks are things like, I think the really different, one of the things I see is really different between the way Kubernetes works and the way we've traditionally used vSphere is typically your application that runs in a set of VMs doesn't actually interact with the vSphere control plane very much. It doesn't care. It says, yeah, you gave me a network, you gave me some disks, I'm good. And it's not very common that people will write applications where inside of it, it's like talking back and forth to vSphere and figuring out which disks are actually attached to its VM and which distributed switch it's attached to and all that kind of stuff. But with Kubernetes, we really intertwine the control plane with the application. And this is true for more than just vSphere, but like we start putting in things like volume IDs, volume handles, and these become like globally unique IDs, which say, for example, you just take all your Kubernetes resources and you replicate them. The volume handles are pointing at the same globally unique ID. And if you're not careful, you will wind up with two applications. You know, at best, they get locked out. One locks the other one out of the disks. But, you know, at worst, they both manage to get access.
Wow, that's an interesting perspective, because I remember I go back to those old VM only days, and that used to be considered an anti-pattern to embed too much knowledge of the platform into the app. And from what you're saying, it sounds like people didn't learn the lesson of history, and maybe some of this stuff went down a path of kind of doing the anti-pattern.
Well, I mean, it depends on how you look at it, because you can look at it too, like I kind of view Kubernetes as being analogous to, say, an operating system, where I would want to, you know, control my processes. I can do that via, you know, like if I'm in Linux, I can control my processes, I can list them out. In Kubernetes, I can do the same thing, but with pods, and I can, you know, for example, adjust my number of replicas on the fly by just, you know, slamming a value into the YAML and increasing the size of my stateful set, and let Kubernetes do the scaling for me. But it does require that interaction between the control plane and the application to do those kind of things. Not every app does that, but a lot of apps do. Yeah, and things like the Kubernetes namespace, or the Kubernetes namespace and control plane itself is not a self-contained entity. It's pointing out to external resources. Which is kind of different from a VM, because the VM is more like self-contained. So Valero is our backup application. It's designed to back up Kubernetes resources to object storage. We have a number of different object store plugins. We can talk to S3 compatible, including on-prem things like Minio, AWS S3. We have plugins for Google Cloud, Azure, a whole bunch of other things. And it's possible to write your own. It's pretty open to plug those in. And we've in fact done some of that. Dell EMC Power Protect has done integration with Valero, and they've written an object store plugin so that the Valero data goes directly to Power Protect rather than through some kind of an S3 compatible API. Valero also will snapshot and or back up a persistent volume. And I'll get into kind of what the difference between those two terms mean to me. Valero runs on every Kubernetes platform. So, you know, we've got it running on vSphere, AWS. If you want to run it in Minikube or on-prem, Red Hat, OpenShift, it runs everywhere. It's not tied to the VMware infrastructure at all, or any particular cloud provider. It's part of Tanzu. And we have integrations going on with Tanzu Mission Control, where you can do backup from Mission Control. You can control your different clusters. You can say, hey, back this one up, and it'll trigger Valero. As I mentioned, we've done integrations with Dell EMC Power Protect. So this is actually the core of the Power Protect Kubernetes backup. And Red Hat uses it in their OpenShift as their backup application. So it's gotten quite a bit of traction in the market at this point. And I'd say it's, you know, it's probably, it's gotten a lot of mind share. It's probably it's like one of two backup applications at this point.
Yeah, and just to make it really clear, it is open source, so you don't have to use any of these commercial distributions. It's just that if you do, it's available.
Yeah, and it's integrated. So but yeah, all the source code is there. You can look into just about everything. And we're very committed to maintaining that open source stance with the product. And we've even done that with like the vSphere plugin. We've kept as much open source there as we can.
And it is its own CNCF project too, so that if you want to go down the open source path, you'll find that it is a CNCF project. It's got a Slack channel on the Kubernetes Slack, I believe.
Yes.
And
yes, and you can also get paid support for it through Tanzu if you'd like that. So basic capabilities for Valero, it can back up all your cluster resources, everything in the cluster. You can just say back up everything. You can back up individual namespaces. You can select by label, and the label could, for example, span all of your namespaces and look for things with that label everywhere in the cluster. It gets installed inside the cluster. It is cluster scoped at the moment. We can back up our persistent volume data either using something called Restic or a Snapshot plugin. And I'll go into a little bit more on exactly what Restic and the Snapshot plugins do in a minute. We have things like execution hooks, which are just things that execute, and you can use them for quiescing an application or anything you like, really. It has a backup schedule. It's pretty basic, but it does. You can control it from the command line or by writing CRDs. The command line basically just writes CRDs, and then the server reacts to them. And we can restore into new clusters or namespaces or into an existing cluster namespace. So this is kind of the overview of the Valero architecture without any of the fancy stuff in plugins and all the rest of here. So we have the Valero CLI or kubectl can be used to control it. These write custom resources for Valero, things like backup. And then the Valero server runs inside its own pod, and it reacts to these custom resources, and it orchestrates things. It talks to the API server, serializes things there. It may also call plugins for various things. And then we have Restic is a open source backup file system to S3 application. We've integrated that inside of Valero so that we can back up systems that do not have snapshotting capabilities. And that's kind of a scale out. It's not really scale out, it's distributed. It's controlled by these CRs. So yeah, and actually this is kind of an interesting pattern here because I was talking earlier about backing up the application state. We actually don't want to back up the Valero application state because when you back it up, it's in the middle of doing a backup. So we actually filter that out while that's happening. So the basic thing that a Valero backup does, captures all the resources from the API server, runs through them, serializing them into a tar file in the object store. And we can do things like modify, like we'll strip off a bunch of the labels, time-created stamps, things like that. And it's possible to extend how those are handled. You can select whether or not you want to back up your persistent volumes. Those may get snapshotted via plugins, or they may get backed up to Restic. Execution hooks get called. At the end, we serialize the info about these snapshots or Restic into the tar file. So like with snapshots, your Valero backup consists essentially of all of your Kubernetes resources and then a list of snapshot IDs for persistent volumes. And anything else we've got, we've got some other metadata, and this all goes into the object store. On restore, we pull that tar file that we made down from the object store, look in it, and we start restoring objects, and there's a defined order for it. So we'll do things like custom resource definitions first, namespaces, storage classes, then the volumes, then persistent volumes claims are built out of those, and we get down towards like pods. So the goal here is to get the storage in place before the pods get started. Otherwise, it gets a little wonky. And then there's, pretty much all your other custom resources just get restored at the end. So I've been talking about Restic versus Snapshot plugins. So Restic is, as I mentioned, it's a file system to object store backup application that we use. It is storage system agnostic, but because it's storage system agnostic, it doesn't do things like take snapshots. And it's basically walking across the file system. So you have to be careful, depending on your use case, like one of our sample cases is a log file backup. You don't need to quiesce anything because, pretty much Restic grabs the file and the file is being written sequentially anyway. So anything that you miss is just going to be at the end of the file and you're fine. But if you have an application that's randomly writing in a file and we're walking across it sequentially, you can get pretty bad results with out of order writes being applied. So in order to be safe with this, we need to actually quiesce the application, or you can do something like execute fs freeze via an execution hook. This goes through the file system And so it
Can I
needs
ask
to,
you something, Dave?
absolutely.
That application hook, do those also potentially do things like log truncations and things, or are they
You could.
strictly just KS?
No, they're basically run this command in this pod.
Okay,
So
thanks.
they're pretty open. They're pretty open-ended. Yeah, so if you wanted to do a log rotation first, you could definitely do that. So that's the restic path is kind of the fallback path. And then we have a number of volume snapshot plugins. And these are things that are, when Valero, if you've got this configured and Valero finds a persistent volume, comes to the volume snapshotter and it says, hey, snapshot this volume for me. And then the volume snapshot plugin interfaces with the underlying storage system and does the work. So these are crash consistent because they're snapshots, but it's a per volume thing. So there's no volume groupings. We're not getting cross volume right order fidelity yet. And then Valero's view of the world is essentially the EBS view of the world, which is, hey, I told EBS, Amazon Elastic Block Storage, I told EBS to take a snapshot. EBS says, okay, here's your cookie, here's your snapshot ID. And then it does all of the work internally to make sure that your data is safe. So it will go ahead and move that data to S3, where it gets replicated all over the place. And the life cycle of the snapshot becomes independent of the storage object. So if you lose the storage, or even if you delete the object, your snapshots are still good, and you can clone new volumes from the snapshot. But this all happens internal to EBS.
So can I ask you just, I think I know the answer, but just to confirm that the advantage of this volume snapshot integration is that for certain classes of stateful like databases, you typically want to KS, and you want that KS to be as short as possible. So you kind of temporarily stop the application from doing its normal day job. And if you have this snapshot assist, that snapshot freezes it and the backup happens from the snapshot, so you can resume full operation pretty quickly. Is that it?
Yes, and it's typically, you know, the snapshot operation is much faster than walking the file system and copying the data. So, and it may be much faster to restore from that. So like in EBS, you know, you can do an instant restore essentially, because when you say create a volume from a snapshot, it comes back pretty quickly with here's your volume, and then it fills it in on demand in the background. Versus if we go through the restic path, we have to write all the data into the volume before we can start the application.
Now on a platform like vSphere with the snapshot, you generally don't want to keep those around a long time. Is there anything built into Valero that would keep an inventory or put an upper limit on how many of these live?
Well, we took care of all this when we get to the vSphere plugin. But yes,
Okay.
that was a challenge. That was some of the fun because our plugin is significantly more complex than say the EBS plugin, because EBS does a lot of the work for Valero, and the EBS plugin is like, I don't know, 500 lines. The vSphere plugin, I haven't done a code count yet, but it's up there. It's getting because it has to handle a bunch of things that AWS would have handled for us. And then typically the volume snapshot plugins are block oriented. So we're taking a block level snapshot of the file system. So the Valero plugin for vSphere is essentially a volume snapshotter. So we handle snapshotting and backup restore of the data. So if all we did was take a local vSphere snapshot, if you were to lose your primary storage, you've lost your backup. So that's not a backup. We started referring to these as like local snapshots versus durable snapshots. So when I talk about the EBS snapshot, I think of this as a durable snapshot because I can take this, I can hold on to this cookie, and I rely on the storage system to do the right thing for me underneath. And I don't, you know, from the code's point of view, I don't have to worry about what's happening under there. So we pretty much emulated that. We took that same view of the world inside the plugin, and we're looking at where exactly all this needs to live longer term, whether things are pushed further down to vSphere, whether things move into Valero and Kubernetes, we're not sure yet. But right now, what happens is the plugin for vSphere handles snapshotting, and it also moves the data into S3 storage. We've only got S3 APIs at the moment. It is doing full backups only. We're looking at what the right thing to do there is. There's some commercial solutions that integrate with this. that handle incrementals properly. We have a scale out data mover so that essentially what will happen is the Valero backup goes through, it says snapshot, 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 snapshot. And we want to get that done as quickly as possible because we want all of our data to be as close as possible in time as it can be. Even though, you know, they're not multi-volume consistent, at least they're close. So, you know, baby steps. We're currently, the release version is currently 1.02, and this is handling vanilla Kubernetes. So this is the Kubernetes installed in VMs running on vSphere and using the CSI driver and the FCD CNS stuff underneath. So basically, this is pre-Project Pacific or vSphere with Kubernetes. We're currently in the process of finishing up the 1.10 release, which will support Project Pacific, and I'll go into the stuff we had to do in there to get that working. And so this will support all flavors of Kubernetes on vSphere.
Hey Dave, can you talk a little bit about CBT support in the future and some of the ideas around how incrementals are being conceptualized and how they might be handled? Anything about anything about that aspect of it?
So what we're doing right now is the plugin lives on top of VADP. So CBT is available, and for us, it came down to less a matter of doing the change block tracking, because the APIs and everything, and all this is traditional vSphere. So we didn't change anything for how CBT works on the vSphere side. It came down to us like a matter of how much resource are we putting into the repository, because in order to handle incrementals properly, you need a fairly sophisticated format that lets you like merge down incrementals into your fulls, handles things like deleting incrementals in the middle of your sequence. We're looking at where to put the resource in terms of the open source plugin versus the commercial offerings. So Power Protect, for example, takes advantage of CBT with the plugin and does incremental backups into Power Protect just like any other VMDK.
I'm going to step in here, guys, just for, I know we've got some audience members who these acronyms won't mean anything to, so they threw out VADP, that's the VMware API for data protection. So it turns out that at the storage layer of vSphere, they built in an API that goes back maybe a decade to support these operations for backing up VMs, but they still are applicable to even when you layer Kubernetes on top of VMs as part of your Kubernetes deployment. The CBT is called change block tracking. The idea here is that in practice, most of these stateful apps like databases don't actually rewrite the whole database every day. So if you're doing daily backups, the general stats are that on average, you're going to find only 3 to 5%, maybe even far less than that, actually changed from one day to another. So dating back to the VM backup days, people tried to optimize this out so that if you could manage to make your backup essentially a delta of the previous day's backup, the backup would take up far less storage. And there are actually ways to create what they call synthetic full backups out of this, so that even if it was just the incremental changes, you could still very quickly reinstall the full image of these. There's even a potential optimization on the restore, where if you know that you need to roll it back, you can use change block tracking to get the delta between today and yesterday and only overwrite the things that would take you back to yesterday if that was the goal. So anyway, just wanted to put that in for the benefit of people trying to follow along who aren't always up on some of these acronyms. So
do we have like a VMware bingo card, you know, with all the little acronyms? How many did you use today?
I think it would be a book, not a card.
Yeah, and so as Stephen was saying, like things like full incrementals. If you go back to like the tape days, right? We used to do a weekly full or monthly full backup, and then do daily incrementals, and like a weekly incremental versus the full. And in order to get back to a certain state, you'd start with your full backup, and then start applying incrementals on top of that. And that's just lots of fun. The synthetic full backup is really what you want, where the storage system has merged it all down for you, so that when you do a restore, you don't have to do a full incremental, but you get everything back in one state. But that does require a lot more sophistication in the back end, because we kind of treat, like in the current implementation, we basically treat S3 like tape. We write things into it, we write fairly naively, and then we don't have a sophisticated format in that. So that's things to do. So this is the 102 architecture, which is something that is it's simpler than the 110 architecture. So in this architecture, say we're doing a backup. So we tell Valero to do a backup. It runs through, it's doing the stuff we're talking about before, serializing all of the resources from the API server. It comes along, it finds a persistent volume, and it calls us in the plugin and says, hey, snapshot this. So we go ahead, we talk to vSphere, vCenter, and we say, snapshot this FCD, and that bubbles down to the host, and there's a storage of a typical vSphere snapshot is taken. And depending on what storage you're running on, you'll get different results. On straight VMFS, you'll get a redo log. On a vVol, you'll get a vVol snapshot. But from our point of view, it's all the same. And it's compatible with all the storage in the same way that regular VM snapshots are. And in fact, uses the same mechanisms for VMDK snapshotting that a VM snapshot would. There's no changes in on-disk format for FCDs, except a little metadata that we add. So then we say, okay, we have a snapshot. We give back a snapshot ID, and FCD IDs are globally unique IDs. The snapshot IDs are also globally unique IDs. So we give back this pair, and we say, that's your snapshot ID. And Valero goes ahead and puts that into its tar file, and then ships all that off to S3. Now, what we're doing is in the background, so we said, okay, well, we took the snapshot, but now we have to upload the data someplace. So we have a similar architecture to Kubernetes app. We write a custom resource that says, hey, upload this disk. And we have a scale out data manager. So there's multiple data managers running in the system. And they go ahead and do a little leader election on who should do this disk or this upload request. And then they connect to the snapshot data using VADP. And NBD is network block device. It's a over the wire. It's a TCP/IP based protocol for reading the blocks out of a snapshot or a VMDK. So it kind of comes in from the side rather than coming in through the VM. There's another technique called hot add that we aren't using at the moment, where you actually attach the snapshot to a VM and you do read writes via the regular IO path. So the data manager then goes ahead and moves that data out to S3, stores it there, and then when it's done, it removes the local snapshot. So that was your question earlier, Steve, was we don't really want to leave a lot of vSphere snapshots hanging around, and so we don't. So what we do is we move the data out. It's now, in my parlance, it's a durable snapshot at this point because the life cycle is completely independent of your storage. That is, unless you put your S3 server in the same data store and backed up into it, and please don't do that. So that was the 1.0 architecture, and that handled the vanilla Kubernetes case. And Kubernetes with vSphere, that's the correct term, right? Or, I call it Project Pacific. And that has a bunch of changes in how Kubernetes works, and we had to accommodate that. So one of the things that changes in Project Pacific is the level of permissions and so forth that are available in the supervisor cluster. So Project Pacific takes on integrates Kubernetes more into the vSphere control plane. And we have this concept that's called a supervisor cluster. And the supervisor cluster is a special, if you like, Kubernetes cluster that has a very tight integration with vSphere. And it's designed to let you manage quotas on various groups, give the vSphere admin more insight into Kubernetes, and allow the Kubernetes developer or DevOps person to work with standard Kubernetes APIs. And so it's designed to handle things like multi-tenancy and isolation in various ways. And one of the things that it does is it does restrict all the permissions that are available. You don't get cluster admin, for example, as a user, as an end user of the cluster. There are certain resources inside the cluster that need to be handled through the APIs. They can't simply be written as YAMLs.
Can I ask a question?
Absolutely.
Your slide says it installs Valero in the supervisor cluster. Is it fair to say that the typical mission of it, even though it's installed in the supervisor, is to back up the guests? And to go further, is there any reason to back up the supervisor cluster, or is that something that could be recreated?
Well, it really depends on how you're using it. So we do have the ability to run user workloads in the supervisor cluster. We have the, Gopal was supposed to talk again about data persistent services. Was that the new name for it? And those are going to run in the supervisor cluster. So we're setting ourselves up here to back up these things that are living in supervisor cluster. And there's some shared infrastructure between supervisor and guest. I'll show you in the diagram there, that services guest cluster from supervisor cluster. But there's also the ability to do things straight up in supervisor cluster.
Okay, thanks. Just another point, time check, if maybe you can fit the rest into 10 minutes or so-ish.
I think if we flip through, we can move along. I've only got like 3 or 4 more slides. So the new pieces of the plugin, we added this Valero app operator that is a, So it's an operator that you can install via vSphere, and this gives certain capabilities that we needed. This is the same mechanism we're using for data persistent services, and eventually we're planning to open this up to a lot more applications to run in Kubernetes on vSphere. There's this backup driver that got added in, and this is a common piece of infrastructure between the guest and supervisor. And we've moved our code that actually handles the snapshotting out of our plugin proper and into this backup driver. And this also supports this para-virtualized architecture. So guest to supervisor, so the guest cluster in Project Pacific is designed for really strong isolation. And one of the key points was that things running in the guest cluster should not talk to vCenter, period. And what we've done is we've mediated this through the supervisor cluster's Kubernetes APIs. And there's this pattern called a para-virtualized driver, where there's a supervisor cluster resource that backs a guest cluster resource. So with persistent volumes, for example, in the guest cluster, in vanilla and supervisor cluster, the persistent volume has a volume handle. And on vSphere, that maps to an FCD ID, which uniquely identifies a disk of VMDK. But that requires interaction with vCenter because that's where the database of where the FCDs lives is, and that's where the APIs for connecting that FCD to a VM so you can actually work with it live. In guest cluster, rather than doing that, we built this para-virtualized model, and the PV in the guest cluster has a volume handle, which is actually a PVC of persistent volume claim in the supervisor cluster. And so when you go to allocate storage, the para-virtualized CSI driver first creates a PVC in the supervisor cluster. And then, all the usual mechanisms kick in there, things like quotas and all that happen. And when the PVC is bound, then the guest cluster can bind that name into the PV, and then the usual Kubernetes things happen. But this way, there's no actual communication between anything in the guest cluster and vCenter, at least no direct communication. So we wanted to keep that. We had to keep that model. And so we did a similar thing with our snapshot backup requests. We also introduced the concept of a backup network here based on some other stuff, and that lets us isolate the traffic for the backup traffic from the management network, and it lets us nail down who can talk to vCenter from the supervisor cluster. The guest cluster does not have access to the backup network, or at least it shouldn't. So here's the big crazy diagram of the new architecture. So let's just walk through what happens in guest. So in this setup, you'll have Valero would be installed in the supervisor cluster via the app operator. That gets all the pieces parts for Valero installed, the plugin, backup driver. The data movers, currently you have to install those as VMs from OVFs yourself, and we're working on fixing that. But you have a scale out set of data movers there. And from the supervisor cluster, things work very similar to the way they worked in vanilla. In the guest cluster, you'll also install vanilla. You'll also install our plugin. It will detect that it's running in a guest cluster, and it gets some credentials from the supervisor cluster that allows it to write records into the supervisor cluster. So we go ahead, we go down to the Valero, we do a Valero backup in the guest cluster by talking to the Valero server there, really writing a CR in the guest cluster. Valero does the usual thing, serializing the resources. When it comes to a persistent volume, it calls our plugin. The plugin now, rather than going directly to an API, writes a resource for the backup driver saying snapshot this volume. In guest cluster, the backup driver knows that it's para-virtualized, and it takes that record and it goes ahead and writes a record for the PVC in the supervisor cluster for that backup. And then the backup driver in supervisor cluster resolves the PVC down to an FCD ID. Then it goes back to taking, it takes a vCenter snapshot, says, hey, I took a snapshot, things bubble back up to Valero. And in the supervisor cluster, it starts doing the upload in the background. And then, when the upload finishes, it removes the snapshot. So that's kind of a lot of ins and outs and rounds. Does that make sense? Or any questions on this thing?
Is there support for backup or upload stream resumption if the upload stream is broken?
Yes.
Okay.
Yes. So we do S3 multi-part uploads. If the data mover crashes or you lose the network connection, we come back and we try again. So it's relentless forward progress is the Kubernetes catchword, right?
What type of checksumming is there to ensure that the artifact that's backed up matches what was actually taken? Is there some sort of hashing that occurs to ensure that that's valid and intact?
Not at the moment, and that would be a good thing to add. So we're pretty much relying on all the checksumming and S3 being reliable.
Always a dangerous proposition.
Yeah, but you got to start somewhere. So this is a view of the backup network that is customer defined. So, you can just hook all your pods to the management network and everything works fine, but you're not supposed to do that. So we asked for that originally, and we've gotten some pushback on that. And so with some new changes in vSphere, there's an ability to add a NIC that gets a vSphere NFC label on it, and that will put all of the backup traffic and BD backup traffic onto that NIC. And you can attach that to a separate network. You can attach your data manager pods or VMs that are doing the scale out movement. You can attach those to that network. And we also need to be able to bridge or route traffic to vCenter, but vCenter only from these guys so that they can access the volumes. And we'll have instructions on how to, on at least a sample setup for this, but everybody's network situation is very different. So that's kind of the run through on like Valero for backup. You can also use Valero for migration. So with the object store, so if you use RESTIC, RESTIC is storage system agnostic. So you can go ahead and back up to an object store and then restore that to pretty much any Kubernetes cluster, because it's not tied to any particular storage technology. If you don't have shared storage, vSphere to vSphere, you can obviously use the plugin, take that to S3 and then back down. And then we're looking at how do we migrate clusters that actually have shared storage underneath. And I think Bryson was doing some things with that, and we could discuss how successful that was and what craziness you needed to do that.
That's a great segue. Is this your last slide, Dave?
I have one more, which is just like futures and resources. So, we can come back to those later on.
Okay, so Bryson, on Slack, we've been having a chat about an incident you had where you were trying to move, I think you were trying to move a Kubernetes cluster as opposed to move a workload to a new cluster. Is that true? And had some issues?
So it wasn't actually moving the cluster, it was moving the vCenter that was controlling the VMware cluster. But in doing so, we had to make changes to be able to point to the new vCenter. Also had issues when that happened, not knowing who was actually doing the moving, how they did it, but where the VMs were coming up with different UUIDs.
So moving the vCenter, that you're talking about the VCSA, the vCenter server appliance was migrated?
No, there was a new one.
Okay.
And the cluster was moved to a new one.
Okay, got it.
Yeah, and you're using the entry driver at the moment?
Yes.
Yeah.
And I think you told me on Slack that it came down to needing to update the VM UUID in a couple of places. Maybe you can describe how you did it in case somebody else runs into that.
So there's several things you can run into issues. I mean, we're getting into talking more about PVs than we are talking about like Valero and stuff, but sorry, I'm on call and I just got an alert. So the storage communicates, you can communicate with the storage through the vCenter. So one of the first things you need to look at is your permissions. Well, first of all, your cloud config. This is for the entry. So specifically is the cloud config is pointed to the right vCenter. Sometimes people can move you to a different vCenter and not tell you. And then once you know that's on the right one, sometimes if they've moved you to a new vCenter, they may not have set up the permissions correctly. So we need to make sure those permissions are set up correctly. And then even with the permissions set up correctly, we've encountered something weird lately with our PVs where it seems like there's still some connection to the vCenter, even after restarting the controller manager and the kubelet on all the nodes. So we've found that there's something in the control plane that's still connecting there. And we found the best way.
The old vCenter or the new vCenter?
This would be, even without changing the vCenter, say the permissions are wrong and they change them and they say they want you to retry. It's like it has a still connection and like it doesn't get the updated permissions until you restart that connection. So I don't know what service there is. We thought it would be the controller manager. And we started restarting several things. And then the thing that we found that just ultimately works is just rebooting each of the control plane nodes. And then that's if like there's differences with the permissions. But then the other thing we ran into lately is where it can happen in a couple different situations, but essentially the VM is re-registered with vSphere and it gives it a new UUID. And the deceptive thing there is when you look at your node from the Kubernetes side, if if you look at that, there's actually two places in that node definition for the UUID. And in one of those places, it automatically gets updated, and the other place it doesn't. So then you end up with the controller manager saying, hey, I can't find this VM, and hey, I can't find a VM with this UUID. So the fix there was to correct that second place in the node definition, and then it was able to find it, and then it was able to
So
set
where
up.
is this node definition located?
Oh, it's just like a get nodes, Kubernetes kube control get nodes.
Okay, so you can use kubectl to
You can
fix
do
it?
yeah, kube control edit node and update the UUID. Wait, I can't remember. You might have had to patch it. I can't remember.
Yeah, that's kind of an interesting thing to happen there, where the VMs, so the VMs running Kubernetes were simply switched from one vCenter to another. And otherwise, they're pretty much running the same thing. They get all the same volumes attached, same networking, all that. But yeah, definitely there's that interconnection between the Kubernetes control plane running inside the VMs, talking out to vSphere and vCenter. And yeah, that's definitely an interesting case there.
Can I ask
Makes
what
sense.
why this is coming up that you want to move VMs from one vCenter to another?
I mean, it could be something as simple as you're running a different version of VMware and you set up a new vCenter with the new version and you can move it over.
Okay, I got it.
Or you're having issues on one vCenter and you want to try it on another vCenter, or you're migrating to new hardware, which maybe just build out a new vCenter with new hardware.
Mm-hmm.
Yeah, one other thing that we saw, specifically going back to like the persistent volumes, was trying to use the topology zones. Was that we found the same thing if we updated the storage class with the new topologies, and the tags were all set on the vCenter, it would report back that it couldn't see them until we restarted the controller manager and several different controller plane services. We found that we just had to reboot the control plane nodes to ultimately get like a connection restarted that wasn't like, oh yeah, now I see them.
Yeah, actually, did you move? So when they moved the VMs, did they didn't shut them down?
Situation. I've had various situations lately.
Yeah.
Merging all of them together. But what was your question?
No, when they moved the VMs, they didn't restart them.
No, they were like a hot. They stayed up the whole
Yep.
time.
Yep. So that explains at least, marginally why the connections remained to the original vCenter. So they never got an indication. They didn't really know they got, they didn't get when you restarted them, then they reread their config and attached to the new vCenter, but the network connection would have remained open to the original vCenter.
But
Maybe I'm ignorant here, but can you fill me in on how you'd manage to do this, to move a VM across vCenters while it was still running? Is that moving the whole ESX host to a new vCenter, or is it some form of
XVC motion should do it, right?
Okay.
Because the VM motion is really a host-to-host thing. And so you just coordinate between the two hosts, and they push the memory state and the processor state over, and eventually they go, hey, flip the switch. It's pretty cool.
Okay, well, it strikes me that I'm conjecturing here, but maybe this is just something that the team didn't think of when they were writing test cases for this, but we'll take this back, and it does make sense now that there is utility in being able to support this scenario just to minimize outages and impacts when you move or update vCenters. So.
Yeah, I think what we're going to see is a lot of, when you come at it from the Kubernetes point of view, that's not necessarily the way you think about things. VMs, coming out of the cloud world, you would never move an EC2 instance from one AWS to another. You know, you simply can't move them across regions. And other than that, there's no change in the control plane. Whereas VMware, you know, we can do a lot of these things. And if you're looking at from your VI admin point of view, it's like, that's a VM. I moved the VM. What's the problem?
Okay, well, thanks, Bryson. That's maybe, I don't know if anybody on this call is going to have that use case, but these things get recorded, so you never know. We'll try to maybe backfill this even into the documentation to save the next person. And for things we can do going forward is maybe make it not so difficult to support this this kind of pathway.
Yeah, I think like a simple thing would be if it reacted to the change in the config and immediately dropped the connection and restarted. That would probably have been the expected behavior that you wanted.
Well, that or even just after restarting the controller manager, I kind of expected that I might have to restart the controller manager to pick up the new change. But the fact that, you know, restarting that didn't restart that connection.
Okay, well, thanks. We're at the top of the hour, but I've got a couple housekeeping things before we go. The first one, this group maintains a YouTube playlist, and there was a slight delay, but the CNCF had their recent online conferences, the Cloud Native China and the KubeCon Europe, and the video recordings of those sessions have been posted. The one in Europe was a summary of best practices for running on VMware hypervisors, not just vSphere, but we also covered the so-called desktop hypervisors, Fusion and Workstation. And then the China event covered migration to out-of-tree cloud provider, and of course, CSI is the out-of-tree implementation of storage. The final thing is going forward, Kubernetes project-wide. They've had incidents with Zoom trolls, and they're tightening down security, so we have to have a passcode on future meetings. I didn't want to do it today, so the rule is actually you either have a passcode or a waiting room, but a waiting room is kind of intensive for people who join late because you've got to pay attention to the participant list, and it's easy to have somebody floundering there when you didn't notice them. So I'm going to add a passcode. Let me pause the Zoom recording just in case the trolls watch the recording. So unless anybody's got any final items, I'm going to close this down till next time. And one thing that you're free to bring up, if anybody's got ideas for topics that they want covered in the next meeting, which will be first week of November. We've got one carryover where Gopala is going to return and cover the changes that have happened with vSphere 7 Update 1. But I think we'll likely have room for one or two other things if anybody would like to suggest something either now or write it in the notes document later. Also, Dave, if I can get a link to your slide deck, I'll go paste it in the notes document after the meeting ends.
Okay, I'll send it over to you.
Okay, thanks. So going on, last call for any final remarks. Okay, well, thank you everybody for attending, and I'll get the agenda notes doc updated and the recording posted within a few days. Bye.
Thanks.